last presentation of this session, I would like to welcome Smriti Chaulagain from the School of Natural Resources at the University. Okay. Okay. There you go.
Good afternoon, everyone, and thank you everyone for being here. And I'm Smriti and I'm actually postdoc at Biological System Engineering at University of Nebraska, Lincoln. So today in this presentation, I'm going to talk a lot about Platte River. We have been hearing a lot about Platte River since morning, and but I'm going to explain how Platte River is changing and why the study of changes in the river system, including for water management, as well as for conservation of river ecosystem. So, as we know that Platte River is one of the tributary of Missouri River, and it flows through the heart of Nebraska. So it is one of the critical source of drinking water for communities like City of Lincoln, and it also supplies irrigation for farms along which are along the valley of Platte River, and it is also the habitat for endangered species such as the whooping crane and piping plover. And some of you who are from Nebraska, they might be already familiar with the Platte River, that it is also one of the great stopover point for millions of migratory birds like sandhill crane. However, rivers like other parts in the world, Platte River is also experiencing some of the common issues such as the upstream diversion, and flows has been regulated by the dams. Because of that, we have seen a lot of changes in flows in terms of magnitude, frequency, duration, and timing of the flows. And one other common issue is Platte River is also facing the drought. And as a result, once widened channel, we are saying that it has narrowed into smaller channel, and we are also seeing increase in the vegetation and the floodplain and the banks. And as a result, it is impacting overall habitat for the endangered species. And some section of Platte River has been maintained by several organizations for habitat restoration purposes, but as a whole section of the Platte River, there are some data gaps like long-term analysis of vegetation and channel morphology. And from our study, we wanted to fill that knowledge gap by determining long-term changes of channel morphology as well as in the vegetation, considering climate factors and also the changing the flows, so that we can have a proper information for a sustainable management of water and as well as habitat restoration. So actually this research is directly inspired from our previous research that we performed on Rio Grande in New Mexico, which is also facing severe or long-term drought. And for that case, we determine how river vegetation and channel morphology are responding with climate variables, considering the drought in New Mexico. And similarly, Platte River is also facing stress from the drought. So we got motivated that since Platte River is a new system for me, I moved from New Mexico to Lincoln not a long time ago. So we wanted to figure out like how the river system in Midwest respond with hydroclimate variables changes as in comparison to rivers in Southwest arid region. So this paper is already published, so if you guys are interested to know more about how river systems are responding with climate change or hydroclimatic variables, then I will provide the link here as well. And so for this project, we have two major objectives. First one is to determine or quantify the temporal and spatial trends in river vegetation changes and channel morphology changes. And our second objective is to correlate that changes with hydroclimatic variables And I have been saying hydroclimatic variables are right here. For climate factors, we will be using temperature and precipitation, and for hydrological factors, I will be using flow variables for Platte River. As I mentioned, this is Platte River is the main focus, but for this study, I will be focusing on this section of Platte River that is on Nebraska that extends from north and south Platte countries to Missouri River countries. And for this study purpose, I'm dividing this section of Platte River into 4 different segments, and first segments that extend from North and South Platte to Lexington, and second one from Lexington to Chapman, which is also the data rate section, and which has been highly managed. And the third section that will extend from Chapman to confluence of Loop River, and the last section that will extend from Loop confluence to Missouri River. And we divided this race into 4 different segments based because they reflect the historic management and as well as hydrological reasons. For example, Reach 1, in case of Reach 1, about 75% of flows are being diverted for public power plants, and water will flow back to Platte River only on Lexington. And as I mentioned before, Rates 2 is one of the data rates section which has been managed by Platte River Recovery Platte River Recovery Implementation Program. They have been managing that section for habitat restoration purpose, and Rates 3 is one of the less managed sections. And the last race, Reach 4, that is hydrologically different from upstream basins. After the confluence of the Loop River, that section, the flows in that section is highly dominated by groundwater flow, whereas the upstream section, their flows is dominated by snowmelt water from Rocky Mountain in Colorado and Wyoming. So for this project, our primary data source are the satellite data, which are freely available, and we are using data sets from Landsat image 5, 7, 8, and 9. And we will be also using Sentinel-2 imagery, even though they are available from 2015. We are using Sentinel-2 as well because Landsat image resolution is in only 30 meter, and even though Sentinel-2 imagery is available from 2015, we will be able to get more detailed information from Sentinel-2 imagery as well. And after selection of data sets for our purpose, we will be doing analysis in the cloud-based platform Middle Earth Engine, and we are planning to use one of the most widely used machine learning algorithms, random forest, and we will be performing land cover classification for every 5 to 10 years, with assumption that riparian vegetation may not change within that time period. Since Landsat image resolution is only 30 meter, we may not be able to capture some of the detailed information like vegetation species. And for that purpose, we will simplify land cover classification into few numbers like riparian vegetation, weighted channel, open space, and croplands nearby or within our study boundary. And after that, we will be correlating the changes in vegetation and channel morphology with the condition variables. And finally, our last step will be to verify our data sets. We will be, for that purpose, we will be verifying only for one rate where we have data sets. It has been collected by Platte River Recovery Implementation Program. So this project is in the early phase of our project, so we don't have results yet. But I'm going to explain some of the expected outcomes that we will be producing from our analysis, and first one will be the historical analysis for 4 decades of time period. And we will determine the temporal and spatial changes in vegetation and channel morphology over 4 years time period. And our second most important outcomes from our results will be the evaluation of management practices for, especially for Phase 2, where a lot of management efforts has been going on, like removal of non-native vegetation species like fragmite, which is taking over the river space, and channel has been narrowed, and it has been one of the biggest issues for habitat restoration projects like so that will be one of the important evaluation from our results as well. And finally, from our results, we also wanted to identify the critical locations that has which may be sensitive for changes in the flows as well as in climate factors. So that will help us to understand how in future that if that kind of situation happen and if we want to proceed with habitat restoration effort on the same section, or we need to move on to different section based on that results. But since it is in the initial phase of the project, I have a quick results as an initial results from my analysis. And as I mentioned earlier, that wide braided channel has been converted into the narrow channel, and this two figure represents the line cover classification for 2 time period, 1984 and 2024. And here we can see that how much channel has changed over the period of time. And so we are performing this project in collaboration of Flat River Recovery Implementation Program. And the main purpose of the collaboration is to exchange data and results between 2 organizations. And I think I forgot to mention before that this project is actually funded through USGS 104B to Nebraska Water Center. Since the funding is not huge, so we don't have budget for this data collection. So we are collaborating with Flat River Recovery Implementation Program to have a data exchange and share our results as well, so that we will also get information for habitat restoration project. And finally, here I have shared some of the contact information to our PIs in this project, and if you have any questions related to this project or need any representatives. Thank you.
Are you able to differentiate between the emergent macrophytes in the river and the riparian covers?
Yeah, actually, for in case of riverbanks, in Landsat image, it's not that great to classify vegetation into different species, but we would like to do that one. Maybe in future when we are able to get high resolution images.
Do you think that, like knowing the interactions between water and a macrophyte versus water in a riparian cover, like how does that inability influence what you can kind of draw from?
Yeah, that's a great question. I don't have an answer for that.
Sorry, thanks.
Yeah, for now, in this flows, we are only doing like a statistical correlation between flows and vegetations.
So are you talking about, like, you are talking about future classification of vegetation species in riparian area, right? So if you get like satellite data sets, even high resolution, how do you correlate with the classifications? Do you have some data sets? Or will you collect some any ideas
That one,
for the classification as well?
yeah, for classification purpose, In some section, there are databases and some of the organizations, they are actively collecting vegetation species data as well, where we would love to do that and compute. And basically, yeah, and for the ground-based measurement, this is the satellite-based analysis, but in case of the ground-based measurement, we would like to see how the vegetation communities are changing and how much native vegetation species are being replaced by non-native vegetation species, since that is also really important for restoring endangered species in some of the major ecosystem.
Thank you.